Hi, my name is Thomas Kling, and I am Chair of the Physics Department at Bridgewater State University. In this series of videos, you will learn more about the opportunities in physics at Bridgewater State, both in the classroom, in research labs, and together with fellow students. We have short videos highlighting different areas of focus in the department by both faculty and students. If you have questions about this presentation, you can reach me by emailing physics@bridgew.edu. Enjoy our videos.
My name is Nick Bryden. I graduated from the Physics Department at Bridgewater State University in 2017, and I've been asked today to briefly discuss my time there, my experiences, and how they helped prepare me for the future. I often look back at my years at BSU very fondly, and I do truly believe that they were some of the most formative years of my life. I think the greatest strength of the department, among many, is the exceptional mentorship opportunities that are offered there. I was personally fortunate enough to work with Dr. Thaya as both a student and researcher in his biophysics lab. I grew immensely in both of those roles and thoroughly enjoyed my time. I also benefited from other connections made available through the department. I worked as a researcher at Northeastern University for 2 summers, which was a great chance to work in a graduate lab. And I was also able to work as a metrology engineer at Plymouth Grading Labs for about a year after I graduated. I'm currently pursuing my physics PhD at the University of North Carolina at Chapel Hill, and I often find that I was prepared very well by the physics department at BSU for this role. The coursework and teaching and research experience that I had at BSU all together gave me the skills and work ethic that you need to be successful in graduate school. Overall, I would say that BSU combines great teaching and mentorship, but also first-class research opportunities, which for me personally was a life-changing experience.
Hi everyone, my name is Dr. Martina Arndt and I've been a faculty member in the physics department for 20 years, and my field of specialty is solar physics, and I study the upper atmosphere of the sun that we can only see during total solar eclipses. And during a total solar eclipse, the shadow that the moon casts is very, very small, so we have to travel all around the world to make observations of the sun. And I've been on 12 eclipse expeditions, most recently to Chile and Argentina. And for this expedition, I was able to bring along 3 students from Bridgewater, Dan, Sarah, and Rydia, and all of us were able to see the total solar eclipse and gather lots of good data from it. And this is what an eclipse looks like, where you see the upper atmosphere of the sun, the magnetic field, and the plasma, and the measurements that we make help understand larger problems like why the corona is actually hotter than the surface of the sun. One of the great things we try to do for all of our students is give them the opportunity to present their scholarship at conferences. Riddy and Sarah joined me in Hawaii in January for the American Astronomical Society meeting. And we've had students work on projects with me studying exoplanets and binary stars, and they also get to share their work at conferences, do their honors theses on these topics, get credit for this work, and even get paid to make some of the observations. We have so many opportunities for astronomy-related activities, both in the class and outside of the class. We have classes on astrophysics, astrophysical imaging, general relativity and cosmology, computer simulations, and we even have the opportunity for students to do summer and semester grants on and off campus. Some of our students have gone on to graduate school at Wake Forest or the University of New Hampshire or UMass Dartmouth, and we've had students do work at the Harvard-Smithsonian Center for Astrophysics and Space Telescope Science Institute, and we even have a student this summer accepted in a prestigious summer research opportunity at the Maria Mitchell Observatory. We really hope that you consider coming to Bridgewater, and if you have any more questions about what it takes to be involved in astronomy and astrophysics at Bridgewater, please feel free to reach out and email me.
Hi, I'm Adam Jabba.
Hi, I'm Zach.
Hi, I'm Dr. Thaya. Along with Adam and Zach, I'm going to take you to the Biophysics lab to talk about the biophysics research that we do here at BSU.
Welcome to the Single Molecule Biophysics lab here at BSU, where we use lasers to trap single DNA molecules and study the interactions of cancer drugs with DNA. That setup that you see here uses finely focused lasers to trap tiny objects, and it's known as an optical tweezers.
The neat thing about this optical tweezers setup was entirely built by our undergraduates. So you can see in the bottom of the tweezers table, we have all those people who have done projects and contributed towards these optical tweezers.
What you see here is a magnified image that we see during our experiments. The bright spot you see in the center is the focused laser. That's where our optical trap is, and you can see that there's a bead being held by that laser. You can also see there's another bead that is attached to a glass micropipette tip. What you can't see is a single DNA molecule that's attached between those two beads.
Once we have a single DNA molecule trapped using the optical tweezers, we can introduce various chemical molecules that are either cancer drugs or potential cancer drugs and study the interactions. We also present our work at international conferences, all expenses paid by the university. The most recent one being us traveling to Peru, which gave us a chance to visit one of the world's 7 wonders, Machu Picchu.
The pennants of several leading universities in the back wall of the lab is where our graduates have gone to pursue their PhD with full scholarship. We have also produced an incredible amount of workforce towards leading industries. As we thank you for your time, we hope to see you joining us and take the path of success, as all our researchers did. Thank you.
Hi, my name is Zoe. I'm a senior in the physics department at Bridgewater State University, and when I graduate this May, I'll be teaching high school physics. It's a great time to want to teach high school physics and to be a part of the physics department at Bridgewater State University because we've just recently started our physics education research group. We have a lot of faculty members who support us, who have research experience, and who have experience teaching high school physics themselves. And a lot of us in the group have worked on research projects or have done internships with local schools. Personally, I've done an undergraduate research project on physics education, and I've been a teaching assistant for a lot of our introductory physics courses, which I love doing. It's a great group to be a part of because everyone is so passionate about teaching and learning and sharing physics with others. And overall, the physics department at Bridgewater State University is the best community I've been a part of. The professors, the faculty members care so much, and there are so many diverse interests and projects taking place. So you know when you come to Bridgewater, you will be supported and you won't fall through the cracks. You will get to work on something amazing and take it with you when you work on physics beyond.
Hello everyone, my name is Samuel Serna. I'm an assistant professor at Bridgewater State University, and let me guide you through the photonics and optical opportunities at Bridgewater State. I am originally from Colombia, South America, where I got my undergrad in physics engineering. I went to Europe to continue with my grad studies, and then I came to the US to do a postdoc at MIT, and now I am an assistant professor at BSU and a visiting scientist at MIT as well. So there will be a lot of opportunities and collaborations with MIT, WPI, and other high-level institutions around the state. The work at Bridgewater State University is a natural consequence of 20 years of development from the valuable faculty we have. The idea behind photonics is to use light instead of electrons in order to consume less power and to have higher bandwidth. It means that it will be cheaper, so lower cost and more efficient. Some of the latest grants we got at Bridgewater State are highlighted here, and as a matter of fact, we appeared at MIT News during this week, thanks to our efforts in those new programs and training of new professionals for this high-tech new industry. Some of the applications of this photonics world are not limited to, but mainly about telecom, RF, sensors, and lidars. So if you are interested in any of that, please Google it and check it out. Those are pretty hot topics, and they are at the core of many of the societal challenges nowadays. So here is some schematics, but the idea is that you would have something like this. So those are chips. I have thousands of chips here. And then the idea is to control light at that level. So it's an electromagnetic field that we can confine, squeeze in that very small size. Before ending this presentation, I want to show you that we are a pretty active community. And this is the map of the world of the different student chapters. So you will have the chance to travel a lot, to be in contact with many of your undergrad peers around the world, where you can share experiences and so on. So I hope to see you here at BSU working with us, and please let me know if you have any questions.
Hi everybody, my name is Allison Daubert. I am the teacher in residence for the physics department here at Bridgewater State University, and I'm going to talk to you about our physics teacher education program. Our physics education program is a double major in physics and secondary education with a physics teaching certificate, and you can just do it in 4 years, start to finish. We have opportunities to become a paid peer tutor or learning assistant, and you can do research with our physics education research group as an undergraduate. We have scholarships available specifically for students planning to become science teachers. Physics is one of the most in-demand teaching fields. High schools consistently rate physics as one of their highest need jobs to fill. The pay and the benefits are excellent. The average teacher in Massachusetts makes about $78,000 a year after just 10 years of teaching, and that's just for a 9-month job. So you have holidays and summers off, and on top of that, many teachers make about $6,000 to $8,000 a year for extracurricular activities. Teaching high school physics is just fun. The average high school teacher rates their job as being equally satisfying to a private sector STEM job, and the average high school physics teacher says that their job is actually more intellectually stimulating than the average private sector STEM employee reports. It's just a wonderful job to have. When I was a high school physics teacher, I used to look forward to going to the classroom every day to do physics with my students. And they were able to achieve some really amazing things. If you think that you're at all interested in becoming a high school physics teacher, please reach out to the physics education faculty. That's Dr. Jeff Williams and myself, Allison Daubert, and you can email us. We would love to chat with you. And I hope to see you all here in the fall.
Hello everybody, this is Dr. Elif Demirbas. I'm one of the Photonics and Optics Engineering faculty member here at Bridgewater State University. My expertise is on semiconductor lasers based on quantum dots. We can change the emission wavelength of these lasers from telecommunication region to mid-infrared region, and they can be used in various applications such as fiber optic and free space communication, imaging, sensing, LiDAR for self-driving cars. One of my main research interests is to use these lasers in LiDAR applications and to integrate these on silicon wafer to make it cheaper and smaller. In our research lab, students are going to get a chance to build optical and electrical characterization setup by using the state-of-the-art equipment that we recently purchased. In addition to research opportunities in our lab, students also get hands-on experience by working on optical kits in courses. They build laser-to-fiber coupling system that they can couple the laser light into fiber optical cable. This is a system is fundamental of data communication. They also get chance to present their work in various conferences and symposiums. Here at Bridgewater State University, we aim our students graduating from this program to get jobs from photonics and optics related companies, as well as to go to engineering programs. Hope to see you on campus in the future, and take care.
Hey guys, what's up? I'm Adam Jabak. I'm a graduating physics senior, class of 2020. I'm both really excited and sad to be leaving BSU actually. I'll be going to the University of Pennsylvania next fall to do my PhD in biochemistry and molecular biophysics. So that's pretty exciting. But on the sad part, I'll be leaving BSU's physics department, which has been more like my home for the past several years. I transferred into BSU not really knowing what I wanted to do. I was fortunate enough to take a general physics course that I found pretty interesting, and it introduced me to Dr. Thaya and the physics department. Later that year, I learned about an opportunity to do undergraduate research with Dr. Thaya using optical tweezers, which basically is a physical technique that uses finely focused laser beams to trap tiny objects. So in the lab, we used optical tweezers to trap individual DNA molecules and study their interactions with potential cancer drugs. That opportunity was really meaningful to my success at BSU. I was trained to become a better researcher and scientist. I also had the opportunity to travel to national and international conferences to present our work. At these conferences, I had the chance to network with graduate students, postdocs, and other leading pioneers in the field. So those were both fun and very educational. Altogether, I believe the physics department at BSU is an awesome environment. The student and faculty culture is very welcoming. There's a tremendous amount of support of resources and support to achieve your goals.
Hi everyone, my name is Professor Devaney. A lot of my students call me Dr. D, and that's great by me. That's me right here. I run the Atomic and Molecular and Optical Laser and Cooling Lab at BSU. I also do theory. I like standard model particle physics. I have a bunch of projects I work with students on, pretty much anything, electronics, optics, physics, you name it. A lot of the students in the past that have worked with me have gone on to get great jobs in industry. Here's a group of more students I work with, and if you're interested in the long history of it, you can read a review article. It's called 8 Miles and a Couple Antiparticles to Bridgewater State College. It used to be college. I've been here for 20 years. I got here after a PhD, undergrad in mechanical engineering, PhD in atomic collisions, postdoc at Oak Ridge National Labs with the United States Fermi Award winner, and then work at CERN making particle-antiparticle pairs. In my laser lab, we do cool things like, you can check this video. And in this video, you'll see that we use lasers to cool and trap atoms to slow them down and act quantum mechanical. And there's the 6 beams converging on the atoms to cool and trap. And eventually those atoms can be used as cold atoms or qubits for quantum computing. And that's how I got involved and started the Photonic and Optical Engineering program at BSU. And was lucky enough to get some nice grants and have some nice articles. And now we have a bigger department. And will soon be the Department of Physics and Photonic and Optical Engineering. Hope you come and join us. Take care.
Hi, my name is Thomas Kling. I'm a theoretical physicist, and I have to tell you that I think that my job is the best job in the world. I get to think about fun things, share fun things with students in my classes and my research, things that are really surprising and interesting and fun to learn. In my classes, I get to teach really neat subjects that you don't see often at the undergraduate level. Classes like nonlinear dynamics and chaos theory, general relativity, computational methods. These are really fantastic opportunities for students to think deeply and really learn something new. We have a lot of fun here at Bridgewater with these classes. Students are an integral part of my research. I published 6 papers with student co-authors, and my most recent paper with Eric Grotz, Kevin Roebuck, and Tim Waite was named the Editor's Choice article in the February 2019 issue of General Relativity and Gravitation. What was really neat about this honor was that the journal sent a tweet about our work. That tweet included a movie of our research that showed how our students wrote computational code to model black holes and light rays around the black holes. All the code shown, including the visualization, was written by Bridgewater students in collaboration with me. I'm really excited about my next series of projects in numerical relativity, which will make use of the supercomputer at the Mass Green High Performance Computing Cluster. We're going to be writing new parallel processing computer code to use graphics cards to have a high throughput of calculations that will let us look at gravitational lensing by black holes and gravitational lensing by superclusters of galaxies.
The Bridgewater State University Physics Department has an observatory with a 14-inch telescope, S-big CCD camera, filter wheel, and even adaptive optics. Our BSU Experimental Astrophysics Research Team, BEAR Team for short, is funded by the NASA Space Grant Consortium. It grants us $10,000 a year in student pay to image exoplanet parent stars and Type 1a supernovae, process the images, and analyze the data. $15,000 in additional funds are available each year to support student research projects pertaining to NASA's mission. Our observatory also houses an extensive outreach program which is open up to 4 nights a week. Our student employees run telescopes and they find objects like the Orion Nebula, the Ring Nebula, the Andromeda Galaxy, so that people from the community can come to our observatory for free and see these objects, often for the first time. Our students also use the observatory to take pictures of astronomical objects through colored filters. Those can then be combined to create true color images of the object, like the one behind me, the Eagle Nebula, taken by alumnus Adam Gustafsson.
Hi, my name is Sarah Oriema. I'm a senior physics major at Bridgewater State University, and I'll be graduating in May with my bachelor's degree. I actually got accepted to a physics PhD program at the University of New Hampshire, where I will be studying solar physics, and I can attribute most of my success to the Bridgewater State University physics program. As soon as I transferred here in 2017, I knew that the department wanted me to be a successful student, and they saw the passion within me. I gained valuable research skills. I got to travel halfway across the world, fully paid for, mind you, to do a project on the solar eclipse. I gained amazing study habits, amazing friends through the department, and I am very thankful for the time that I had at BSU. Unfortunately, I do have to graduate, so I won't be with them for too much longer, but I'm happy that I got to be there, and I want to thank them. So, great mentorship, for one, and I can say that